going to be talking about today, this video will probably go pretty quick. It's not very complicated. We're talking about linear and angular velocity. And so basically on 1 through 6, all it's asking you to talk about is angular displacement. All right, like how far is something moving in radians. So right now what we'll do is we'll look at problem number 6, problem number 1, which says 6 revolutions. All right, something you're probably going to want to do. You need to realize that 1 revolution is equal to 360 degrees. Okay? And when I say 1 revolution, in radians, that would be considered 2 pi radians. So we're at 2 pi radians right there. Okay? So 6 revolutions would be 6 times 2 pi radians. And so the angular displacement, like how far have we traveled in radians? We've traveled 12 pi radians. Now that's the exact answer. Okay, that's the exact angular displacement. Now that's approximately equal, if you multiplied it in the calculator, if you took 12 and multiplied it times pi, 37.7, round to the nearest 10, we would say that's 37.7 radians. Now, what is 1 radian approximately equal to? Do you guys remember that? That's approximately equal to 57.3 degrees. So if I want to know how many degrees that would equal, you could take this 37.69 or 7, all right, and you could multiply it by 180 over pi. And that would give you how many degrees? 2,160 degrees, which is the same as doing what? 6 times 360. Now, just remember, real quick, I did 180 over pi. That's the approximate value of 180 over pi is at 57.3 degrees. If you did that in the calculator, you would see that 180 divided by pi. In case you're wondering how I got that. That's how I got the 57.3 degrees that I wrote earlier. Okay? So if we go back here, and I say, what's the angular displacement? This is your exact, and this right here is your approximate value. So that's all you have to do when you're finding your angular displacement. Okay? So think of it this way. In a circle, if I were to do 6 rotations, right? 1, 2, 3, 4, 5, 6. How many degrees did I travel? I traveled 2,160 degrees, but if I would convert that to radians, that's 37.7 radians. That's your angular displacement. So that's the first part. That's pretty easy on the first 6 problems. But now we go to what? Not angular displacement, but angular velocity. So what is angular velocity? Theta is your angular displacement. That's what theta represents, your angular displacement. But angular velocity is your angular displacement over what? Over time. So it could be over seconds, it could be over minutes, it could be over hours, okay? But it's basically theta over t. So our W, which represents angular velocity, is theta, our angular displacement over time. So if we were to do, say, problem number 7, all right, all you have to do is do 2.6 times 2 pi radians, so make sure you put 2 pi radians, over 6 seconds. And that will give you your approximate answer in radians per second. Which basically means every single second that you get, remember, what's 1 radian equal to? 57.3 degrees. That's how many degrees are traveling every single seconds. So if we go over here and do 2.6 times 2 pi. I'm sorry, you're sitting in a no yawning zone. All right. And divide it by 6. You get what? 2.7 radians per second. This would be 2.7 radians per second. So if I wanted to know how many degrees that was per second, what can I do? If I want to figure out how many degrees that was traveling per second, I could take this answer and multiply it by 180 over 1. Divided by 5 if I wanted to. And that lets me know if I wanted to convert this to degrees per second, that would be 156 degrees traveling what? Every single per second. Right? But all of your answers are going to be in radians per second. For what? For angular velocity. Okay? So that's pretty easy. Now we're going to go down a little bit further. Now we're going to go to the back page, which is linear velocity. Alright? Linear velocity is, imagine if you had, say, a circle. Alright? And right now, that circle had a radius of what? Had a radius of 7 centimeters. What if I made that circle, everybody, I cut it, like you could maybe cut it and roll it out, what? Roll it out into one long line. You understand what I'm saying? If you take a circle and you kind of roll it, take it and roll it all the way out, you can see the linear distance, okay? Well, what's the circumference of the circle? 2 pi r, right? 2 pi r is the distance of the circumference of a circle. So if I said 2 pi times what? Not that, sorry. Times 7. That would be what? 14 pi? So let's see what the distance of this circle would be. Type in 14 pi. My board's resetting. There we go. 14 pi. So that's about 44, we round to the nearest tenth, right? 44 centimeters in length. So if we rolled this circle out and stretched it all the way out, that'd be 44 centimeters all the way around. I want you guys to understand this because when you're trying to find linear velocity, it's kind of letting you know how many centimeters are happening per every single second, or every single minute, or hour, depending on how fast you're going. So right now, your velocity, everybody, your linear velocity is going to be the radius of whatever circle you have times theta, which is your angular displacement over time. Well, fortunately, for you guys, it's pretty easy. Look at this. What do they give you? They give you W. What is W equal to? W is equal to this guy right here. So all you have to do is just take 7 and multiply it to what? 14.3. So you have 7 centimeters. Multiply the 14.3 radians per second. And what's 7 times 14.3? 100.1. So basically, everybody, your answer is this travels at 100.1 centimeters per second. Alright? So the linear velocity of a point rotating at the given angular velocity at a distance r from the center of the rotating object, basically the center of your circle, alright? This one would be traveling at 100.1 centimeters every single second. And what's 100 centimeters equal to? It's 1 meter. So think of a meter stick, right? So if you're going a meter per second is basically how fast this object is traveling, 1 meter per second. And this is, everybody, this is your linear velocity. So if I give you W, and what does W represent? That represents your angular velocity. All you have to do is take your angular velocity and multiply it times your radius, and that gives you your linear velocity. Which makes the next few problems very, very simple. All right? It gets a little bit more difficult when you're doing with problem number 16, Because in number 16, I don't give you the angular velocity. You have to figure it out. Okay? So in number 16, you are going to have to find the radius. You are going to have to find theta, and you're going to have to find time. So you have to find all three elements to be able to find your linear velocity for problem number 16. Okay? But all the other problems, go ahead and you should be able to work them out pretty easy, and we'll figure out number 16 here in a second. All right, number 16 is a little bit hard because you have to figure stuff out, so we're going to make a little clump. All right? Now, I'm going to do something here. You tell me, is this the hour hand or the minute hand?
Minute.
No, I'm sorry. That's
Wait,
the hour hand.
hand.
There's the minute hand. All right, and the second hand, there's not like a little arrow, right? It's just the second hand which goes all the way around like this, right? Oh, yeah. There's the hour, there's the minute, and then there's the second. It goes.
Oh, yeah.
There you go. So right here, I'm going to put the number 12. Here, we put the number 3. Here, 6. And here, 9. And this little second hand has little 60 seconds to go all the way around, right? Okay. So right now, what is the radius of our clock?
3.
That's right. 3 inches. Okay. Now, the second hand goes all the way around a clock, correct? How many seconds does it take to go all the way around? 60. So guess right, the time equals 60 what? No. Seconds, because it's the second hand, right? So 60 seconds. All right, now, the next thing we got to figure out is theta. So right now, if I were to go from like right here, right, and go all the way around, how many degrees did I travel? That's right, 360 degrees. But I got to convert that into radians. You know how many radians are in 360 degrees?
2 pi.
That's right. So put 2 pi radians. All right, so now I'm going to highlight what we have. Ready? We've got this guy, we've got this guy, and we've got this guy. And then we've got this wonderful formula over here. Ready? I'm going to scroll over here. You're not going to believe what I'm going to plug in for R. Boom. Then I'm going to plug in something for theta, 2 pi radians. And then I'm going to plug in something for time, 60. So let's plug them in. All right? So right here, the linear velocity is equal. Make sure, don't just type it in the calculator. Write it down on your paper. Put 3 inches. Here, put 2 pi radians. Okay? Over 60 seconds. All right? All right, so 2 pi radians in 60 seconds. Now, when you multiply that all together, that's going to give you how far it goes in inches per second. This is how many inches it goes every single second. And I think you get 0.3. If we round to the nearest tenth, just 0.3 inches. So just 3/10 basically of an inch is how far it travels, okay, in 60 seconds. I'm sorry, per second, not 60 seconds, per second. Got your inch? So listen, this one was more difficult because what did we have to find? We had to find the W. And what does W represent, everybody? That represents the angular velocity. Okay, like how far is it going around? Like how fast is it going around the circle? Okay? The linear velocity deals with the distance it travels per second. Okay? So hopefully this will help you finish up